Okay, so this is the angle relationships video, part 2. And here we're going to get into some technical jargon about what we call certain angles and how they relate to each other. And it's going to lead into a little bit more complex information about angles and parallel lines. So you're going to want to be able to pay attention to this because it's hopefully going to make things pretty clear. Okay, so the first two words are complementary and supplementary angles. And to get it across, I'm going to use two old jokes, okay? So let's see if I can make it work. Think about it. A complement makes us feel just right, as in a right angle. So a complementary angle is an angle, like a complement, that helps add up to 90 degrees. Get it? Right angle equals 90 degrees. Complement makes us feel right. So a complementary angle adds to the original angle to equal 90 degrees. Okay, well, let's say, for example, that this angle here is 60 degrees. Well, what's the bottom one going to be? Well, it's 30, because together they make 90. So let's say that this is 70 degrees. What's this one going to be? Well, it's got to be 20 degrees. Why? Because it makes 90. So let's say that this is 45 degrees. And you could say, hey, Mr. Chambers, that was bisected. Well, yeah, because it's two equal angles, but together they make 90 degrees. Okay, so if I said to you, hey, this angle is 80 degrees, and you said, okay, this one's 20 degrees. Well, you'd be wrong, because it's got to make 90 degrees, so it's got to be 10 degrees. Okay, now, here's another one, another joke. Groan if you want. Have you ever heard of that old line? You can call me anything, but don't call me late for supper. And this is Rodney Dangerfield, really funny comedian from back in the day. If you just woke up and were wondering what was for supper, your first thought might be, that's a long way from now. So, like the complement joke, the supplement joke goes like this. How long till supper? Supper is at 180 degrees. Answer, whatever it takes to get there. To get to 180 degrees. So let's say that this little guy wants supper. He looks pretty hungry. And he asks the chef, how long till supper? The chef says, whatever it takes to get to that 180 degrees. Now we know that every straight line is 180 degrees, and it's a long way from where you started. So if that's 60, this has to be 120, because they add up to 180. So if that's 90, this has to be 90. The supplement is 90. If this is 130, well, what's its supplement? So you want to go all the way from morning till evening where you get supper. That's going to be 50 degrees. If this is 120, well, then 60 degrees will get you to supper. That's its supplement. So how can we remember the difference between complementary and supplementary angles? Well, if you think of the C's for complementary, you can think of corner. So angle 1 and 2 are complementary because they make a corner, 90 degrees. Angles 3 and 4 here are supplementary because they add up to make the side of the paper. Side supplementary. I kind of like my other jokes better. So what do you need to do? So let's say that somebody draws an angle for you and says, hey, this is 40 degrees. And we want to know what's its complement. Well, what you have to understand is complement means 90 degrees. So 40 plus 50 makes 90. That's its complement. Well, let's say somebody shows you this and it's 40 degrees. And they say, what's its supplement? Well, you have to understand that supplement means 180. So 40 plus how much more makes 180? 140. Complement, supplement. Basic terms as far as angles are concerned. Now we're going to take it up to another level. Everything we've learned so far has been about angles, how we measure them, how we bisect them, complements and supplements. And, you know, to be fair, that's really grade 8 kind of stuff. But how do we make this grade 10 stuff? Well, if we think back to carpenters and all the things that they build, and welders and all the things they manufacture, and pipe fitters and engineers and things like that, we have to understand that angles have a relationship to each other from different points. So anybody with a protractor can measure an angle, but being able to understand how that angle relates from one point to another point, well, that's where you get to be grade 10. Okay, so these two blue lines are perpendicular. By perpendicular, we mean that they're at 90 degrees. Okay, that's what the square corner means. So if we know that that's 90 degrees, can we figure out all the other angles around that corner? Well, absolutely, because if this is a straight line, then this also has to be 90, because 90 plus 90 makes 180. Now, once again, if this is 90, how much is this one? Well, it's got to be 90, because 90 plus 90 makes 180. And if this is 90 up here, then how much is this one? Well, it's 90, because 90 plus 90 makes that straight line 180. So we can see that perpendicular means at right angles, which means 90 degrees. So every point around it is also 90 degrees. Now, if you take them all together, and you go completely around the circle, 90 times 4 is 360. So it makes sense. Okay, now, even if two lines are not perpendicular, we can determine the angles formed from the intersection very easily, because we know that every straight line is 180 degrees, and that supplementary angles add up to 180 degrees. So if this one is 60, we know that this is 120. If we know that this is 60 degrees to here, this one has to be 120, because they form that straight line. If we know that, let's get a different color here. If we know that this is 60 and that's 120, because that makes a straight line of 180, we know that this one also has to be 60, because that 120 plus this 60 makes that straight line of 180. Well, what do you notice about the pairs of opposite angles? Watch this. What do we notice about this guy and this one? They're opposite, but they're also equal. And what do we notice about this one and this one? They're equal. So this forms one of the great basic ideas of linear geometry. When two straight lines intersect, opposite angles are equal. Okay, so if we do that, if this is 110, it's automatic. That's 110. And if I know that this is 110, I know that this has to be 70, because it makes a straight line, which is 180. And if that's 70, I know that this guy has to be 70, because they're opposites. Not that bad. When two straight lines intersect, and let's say this is 80, this one has to be 80 automatically. Well, then this has to be 100, because it makes a straight line. If that's 100, this has to be 100. It's like a logic game. Pretty good. So what would happen if a straight line crossed over a set of parallel lines, like railway tracks? Short answer, all the angles formed around the first intersection transfer the corresponding angles to the second intersection. Whoa. Well, what does that mean? Corresponding. Well, first we're going to do is we're going to talk about this line right here. That straight line, you can almost think of that as like a road crossing over some railway tracks, okay? That straight line is what we call a transversal. A transversal. So what means it transverses two lines. So when we say corresponding, what we really mean is if this one is 50 right here, where's its corresponding angle? It means where's the same angle on the other one? Well, that 50 corresponds to letter E because they're both on the same side of the transversal. Like they're on the same side of the street, on the same side of the railway track. So if this was this angle here, letter C, it corresponds to letter G. If we had letter B, it corresponds to letter F because they're on the same side of the transversal, on the same side of the street, so to speak, in the same area. And D and H. So, short answer. If this is 50, then this will be 50. Now, if this first one is 50, what does B have to be? Well, that's got to be 130 degrees. Why? Because they make a straight line. There's that straight line again. So if that's 50 and letter E is 50 and this is 130, this has to be 130. Well, check it out. Could I find out how much D is and C? Yes, because they're opposite from each other. They're straight lines and they just are opposite from each other. So D has to be 50 and C has to be 130. So if down here E is 50, H has to be 50. If F is 130, G has to be 130. So everything, let's just clean this up a bit. Just so we don't get too messy here. Everything up here transfers to everything down here. So if that's 50, 130, and because these guys are opposite, that's going to be a 50 and this is going to be a 130. You can basically take this whole group and just put them down here. So that'll be 50, 130, 130, and 50. And that kind of makes sense because if the lines are parallel, no angles have changed. Everything stays the same from top to bottom. Nothing has changed. So we can just transfer it all. But here's where it gets to be a little bit more like grade 10. And the idea is we can name all of those angles. Now, before we get all into these guys, let's just discuss for a second what this is. If these are our parallel lines here and here, then we have what we call exterior angles and interior. So if you think of railway tracks, basically what we're talking about is on the inside of the railway tracks. So we have the interior angles. Now, sometimes these angles could be there and there. Now, they're kind of interesting in their position because they're on the inside, but they're on different sides of the interior angles. And same with this guy. Here and here. Let's make those squares, okay? Now, we call these alternate interior angles. Let's see if we can change that color there. Yeah, than that guy. Okay, now the two yellow ones are alternate interior angles. So they're on the inside, but they're on alternate sides. And the two purple ones are alternate interior angles on different sides. But what's really, really, and I'm going to say really again, what's really important about these is that this one is equal to this one. And this one is equal to this one. So alternate interior angles are the same. And you can see it in this diagram right here. All right, now let's clean that up a bit. Let's talk about these exterior angles. So let's say, for example, that we've got right here, an exterior angle here. And let's say that we've got an exterior angle over here. Well, just like the interior angles, now they're on the outside, but it's exterior, and they're on alternate sides. One's on this side of the street, the other one's on the other side of the street. How about this guy? That one's on this side, it's on the exterior, on this side of the street. This one is on the exterior, on the other side of the street. They're called alternate angles. And you can just tell by looking that this guy looks like he's about the same as that one. And they always are. And this guy is the same as that one. And they always are. So, well, how does this help us? Well, and you might want to refer to these diagrams because they talk about corresponding and alternate, that sort of stuff. Essentially, we can work out the math. Well, what do you mean? In each case, each of these corresponding angles are equal, and they also are supplementary angles to their neighbors. So if angle A is 70, okay, so let's just write, yeah, good. So let's write 70 degrees right there. If he's 70, we know that this one has to be 110. Why? Because of that straight line. Okay? Now, we also know that if that's 70, this guy has to be 70. And if that's 70, this guy has to be 110. Why? Because they're opposite angles. And they also add up to make 180s on both sides. And from our last example, we know that we can take this whole area here and transfer it to this area here. So they're all corresponding, all right? So if this one was 70, this one will be 70 because they correspond. They're in the same area. They're on the same side of the street, on the same side of the block, so to speak. If this is 110, this is 110. If this is 110, then this is 110 and 70. And it works out a lot of ways logically because we have straight lines, so they have to add up to 180. We also have opposite angles, so they have to be the same as each other. I mean, it just works out. Now, let's think about the 180 degrees. Look at angles C and E. So let's go back here. Let's clean this up a little bit. Okay, so what we want to do is we want to take a look at angle C and angle E right there. And what do they add up to? They add up to 180 degrees. I mean, well, how do we know that? Let's just go back for a second without getting too crazy. If we said that this was 70 and this was 110, we know that this is 110 and we know that this is 70. Why? Because this one corresponds to that one and this one is an opposite. Well, 110 and 70 180 degrees. Oh, so that would mean that if those are 180 degrees, then these two are 180 degrees. So we can see 180 degrees everywhere. So co-interior angles are 180. When we say co, we mean like combined together because they're in the same spot. Co-interior angles are 180, and co-exterior angles. So that's an exterior, A and G. They're both exterior. They add up to 180. Just 180 all over the place. Okay, but why would that matter? Because we can use this information to check to see if two lines are parallel. If they are parallel, that means that our angles will match up, which is very good. If you're a journeyman and you're installing tiles, flooring, cupboards, windows, rafters, stairs, baseboards, fences, blah, 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 you get the point. Check this out. See if we can do it. Here is, let's do that line. Let's give it some color here. Let's go red. Here is a line. Whoops. Let's go fix up this line here. There. We got a line there. Now let's put in another line right here. Okay, now look at these lines. There's a transversal right there. Now I know I'm not super accurate because we're on a smart notebook and it's got some problems. I mean, it's kind of a cool little program, but it has limitations. Anyway, so what does this mean? This means that we know exactly how to cut these angles. We know to cut that angle right there because that angle has to be the complement, or I'm sorry, the supplement to that angle. Because they both add up, these two angles add up to 180. We know that whatever we cut this angle at, right here, right, has to be, or I'm sorry, right there, has to be what works to make 180 for the rest of the whole pattern to be the same. Now imagine if you're doing something like rafters that actually have to hold up a bunch of snow in the winter, and they have to be able to stand on their own. Or let's say you're putting up stairs, and if you didn't put up stairs correctly, basically, people are going to trip and fall. It means lawsuits. Nobody wants a lawsuit. I don't want a lawsuit. Okay, last one. Now that you understand how angle relationships work, you should be able to determine all the missing angles below. As well, you should be able to measure each of these angles accurately, as well as being able to explain why understanding angle relationships is important. So, for example, let's take a look at this one right here. If this is 90, how much is this one? How much is this one? Well, yeah, they're all 90. Well, why are they 90? Well, because these lines are parallel. And there's your transversal. So they have to be the same. Okay, if this is 25, how much is this one? And this one? And this one? And this one? And this one? Well, if you said 25, you're absolutely right. But why? Well, because the lines are parallel to each other. That's why. Okay, so if that's 25, let's say, okay, so let's go again. So that's 25. How much is this guy? 25, 25, 25. Why? Well, these ones are 25 because they're parallel to each other. These ones are 25 because they're corresponding. Okay, so if this one is 270 degrees, from there to there, so all the way around to there is 270. How much is this one? 270. 270. Why? Well, because these lines are parallel with each other, and there's your transversal. It just shows up everywhere. There, happy cat. So understanding angle relationships is important because it relates to the real world, and that's why we care.